Today we're joined by Mike Thornton, the Chief Technology Officer of ENDRA Life Science. ENDRA Life Science has developed a new medical device based on TAEUS technology. Mike, could you tell us what TAEUS technology is all about?
ENDRA Life Sciences has developed a unique technology based on the thermoacoustic effect that combines two forms of energy, radio frequency and ultrasound, in order to characterize tissue composition. ENDRA's non-invasive imaging approach uses short radio frequency pulses to provide energy that is differentially absorbed and generates ultrasonic waves that can be detected by an integrated ultrasound transducer. This technology, thermoacoustic enhanced ultrasound, or TAEUS for short, provides physicians with a simple, fast, non-invasive, and cost-effective method to determine the presence of fat in the liver. The TAEUS fatty liver imaging probe, that we call FLIP, will provide a quantitative measure called the thermoacoustic derived absorption parameter, or TAP. In physics, TAP is known as the complex relative permittivity, the friction in the system as energy is stored in an electric field. In liver tissue, the complex relative permittivity is highly correlated to the magnetic resonance proton density fat fraction, the current quantitative gold standard in non-invasive, non-alcoholic fatty liver disease assessment.
Wow, Mike, that's really interesting. Can you explain to us how TAP is closely related to fat in the liver?
Sure. With the TAEUS FLIP system, the absorption of RF energy and emission of ultrasound varies with the content of fat in the liver tissues. Fatty liver tissue absorbs less RF energy and emits less ultrasound than healthy lean liver tissue. Thus, fatty liver tissues have lower TAP scores than leaner tissues. The TAEUS TAP score ranges from 33 for lean, healthy liver tissue to 11 for severely fatty liver tissue. For reference, blood has a TAP score of 56, while human fat is 3.4.
Okay, I see. So why is TAP such a good indicator of fat in the liver?
Great question, Erno. ENDRA's TAEUS FLIP system determines the liver fat content by exploiting the change in complex permittivity associated with liver fat fraction seen in patients with fatty liver disease. The current gold standard for quantifying liver fat content is determined by the magnetic resonance imaging proton density fat fraction, known as MRI-PDFF. MRI-PDFF is growing in popularity as a much better alternative to histology for its non-invasive approach that is accurate and largely operator independent. ENDRA Life Sciences is using MRI-PDFF in past and future studies as a gold standard to compare its own permittivity metric of liver fat fraction. Clinical studies have demonstrated an inverse relationship between our estimates of permittivity and MRI fat fraction measures in subjects ranging from healthy to moderate fatty liver disease. By estimating tissue complex permittivity based on its thermoacoustic signal, we can infer tissue fat content with the TAEUS FLIP system.
Oh, thank you, Mike. I mean, this is great. So this technology seems to be very versatile. So in addition to measuring fat in the liver, what other application could this technology be good for?
The potential for TAEUS applications in healthcare is not limited to the assessment of fatty liver disease. As an example, we're developing an application to enable clinicians to see tissue temperature change non-invasively in real time during thermoablative surgeries, removing the guesswork from these complicated procedures. Monitoring of energy-based surgery is just one example of the healthcare challenges ENDRA is tackling today. With enhancements to conventional ultrasound, we plan to revolutionize what clinicians can see and do in real time.